Hello friends, welcome to my channel Academic Made Easy Peasy. If you have not subscribed my channel, subscribe it and also click the bell icon. Question 14. Show that first subdivision matrices is given in the two sides and we have to prove that these two are not equal. That is, A into B is not equal to B into A. That only we have to prove. And now let's get started. So now first let me take only the LHS. So my LHS is, I will write the given matrix. So 5 minus 1, 6, 7 into 2, 1, 3, 4. Isn't it? So now I will check the order of my matrix. So 2 by 2, first matrix is 2 by 2 matrix and next also is 2 by 2 matrix. Cancelling these two, I will have 2 by 2 matrix in the answer. So now, as I have already thought, you just take the first matrix first. Okay, so if I take my first matrix, I have to take only the rows. So if I take only the rows, I will have 5 minus 1, 5 minus 1. So why I am taking twice is that I have two columns in my second matrix. So next will be 6 plus 7 and 6 plus 7. And so now what I will do in the next step, I will be multiplying this. So first element with first element, second element with second element. The same way in second column also. First element with first element, second element with second element. So directly I will be writing it down also. So now I will just take the product for this. Next, 10 minus 3, 5 minus 4, 12 plus 21, 6 plus 28. So in the next step, I will have 7, 33, 1 and 34. So this is my equation 1 for LHS. So now let's move on to RHS. Now RHS. So my two matrices are 2, 1, 3, 4 and 5 minus 1, 6, 7. So now let me check the order of my matrix. My first matrix is of the order 2 by 2 and the second order is also 2 by 2. I will be cancelling these two. So 2 by 2. The final matrix will be in the order 2 by 2. So now I will find the solution for this. First I will be taking only the row from the first matrix. So I will be doing it twice because I have two columns. 2 plus 1. 2 plus 1, 3 plus 4, 3 plus 4. So now I will be multiplying it. So first element with first element, second element with second element. The same thing, I'm writing it down also. And here also minus 1 and 7. You know why I'm doing it like this? Because I have taught you how to do this. So 10 plus 6 and minus 2 plus 7, 15 plus 24 and minus 3 plus 28. So what will be my answer? 16, 5 and 39 and 25. So this will be my equation 2. My LHS, RHS is this and LHS is this. So seeing this, we can automatically say that LHS is not equal to RHS. Why? Because if these two are equal matrices, then the corresponding elements will be equal. Here none of the corresponding elements are not equal. So therefore equation 1 is not equal to equation 2, hence proved. Division 2. So here also two matrices are given. We have to prove that AB not equal to BA only. Okay, so now solution. First I'm taking LHS. So taking my LHS, I have this matrix. So to perform multiplication, first I will find the order. The order of my first matrix is 3 by 3 and second matrix is also 3 by 3. So these two will get cancelled. So 3 by 3 is the order of the final matrix also. So now what I will do is that first I will be taking only the rows of the first matrix. No, so now I will start multiplying. So first row with first column, next with second column, next with third column. No, just like that. Okay, so next I will be writing the product. That's it. Next I will have 5, 8, 14, 0, minus 1, 1, minus 1, 0, 1. So I will mark this as equation 1. So next I will move on to RHS is equal to. So now I will be multiplying these two. The order will be 3 by 3 only. So now I will start multiplying. So now I will be adding to find my final matrix. So here minus 1. Next here it is minus 2 plus 1 is minus 1. Minus 3. And here it is 1. Minus 1 plus 1 0. And 0. 2 plus 4 is 6. 4 plus 3 plus 4 is 11. Next here 6. So this will be equation 2. So compare this equation 1 and 2. Is these two equal? Not at all. Even an element is not equal. So therefore I would say that equation 1 is not equal to equation 2. Hence proved. Question 15. Find a square minus 5a plus 6i if a is equal to this matrix. Okay, so matrix A is given. So now what we have to do is that we have to find for this equation. It's just like a equation. So first we have to find a square and we will find the resulting matrix. So first let me take a square is equal to a into a. This is what a square, isn't it? A square means what? A into a. So first I will take, so a square is equal to, so now I will be multiplying. So 3 by 3 matrix only. Now both also is 3 by 3 matrix. So cancelling these two, I will have 3 by 3 matrix only in the result also. So therefore first I will go with rows of the first matrix. So now I will be multiplying with the second matrix, that is rows with columns. So first column and the second element with second column, third element with third column. So now I have multiplied. So now let's see the sum of this. So a square is equal to, so my final answer will be 5 minus 1, 2, 9, minus 2, 5, 0, minus 1, minus 2. So now this is my a square. So now I will start substituting in the equation. What is the equation given? A square minus 5a plus 6i. What is I? I is what? Identity matrix. No. So now I will substitute the values of a square. minus 5 times the matrix A. What is matrix A? I will be writing that plus 6I. What is I? Identity matrix 1 0 0 0 1 0 0 0 1. So now I will be adding or subtracting. So this one I will keep it as it is. So now 5 minus 1 2 9 minus 2 5 0 minus 1 minus 2 minus I will be multiplying this inside. So 10 0 5 10 1 5 15 5 minus 5 0 plus 6 0 0 0 6 0 0 0 6. Now I will be adding this. So 5 plus 6 is 11. Minus 1 plus 0 is minus 1. Since here it is positive, both the positive matrix I'm adding. This is negative matrix. So I'm just keeping it as it is. So minus 1. And here it is 2. 9. Minus 2 plus 6 is 4. 5 plus 0 is 5. 0 plus 0, 0. Minus 1, 4. So now I'm going to change this. That is negative to positive. So plus 10, 0, minus 10, 0, minus 5, minus 10, minus 5, minus 15, minus 5, plus 5 and 0. So subtracting those two matrices, we will get 1 minus 1 minus 3 minus 1 minus 1 minus 10 minus 5 4 4. This is the required matrix. Question 16. If A matrix is given, then we have to prove that A cube minus 6A square plus 7A plus 2I is equal to 0. That is 0 matrix. So now let's move on to the solution. So solution, first we will be finding A cube. So we know that A cube is equal to A square into A. A into A into A. That is what? A cube. So since we already learned A square in the previous sum, I just wrote A square into A. If you want to write A into A into A also, that's correct. There's nothing wrong in that. Why I wrote like this? Because first we will be finding A square. Then only we will be finding for A cube. So for example, when we have a bigger number, 2 3 4 cube means first we will be finding the square of this number, then we will be multiplying this. No, just like that I have did. So A square we will be finding first. So A cube is equal to, first I will have A square. So twice I will write A matrix, into A only I will be writing. So into A. This A I am writing as it is. This is only for, this whole thing is just for A square. So A cube is equal to, first I will be taking only the rows of the first matrix, 3 into the matrix A. Don't forget to write this. So now I will be multiplying with the second matrix. So first element with first column, second element with second column, and third element with third column. So now let's find the answer for this. Now we'll find the final answer into A. Don't forget to write this A. So 5, 0, 8, 2, 4, 5, 8, 0, 13 into A. Now I will start writing my matrix A. What is my matrix A? Now I will be finding, this is my A square. This will be my A square alone. So now I have to find A cube, no? So this one I will multiply with A. So I will have 3 by 3 matrix only, no? So now I will be multiplying with the second matrix. So first element with first column, second element with second column, third element with third column. So after adding, I will have 21, 12, 34, 0, 34, 8, 0, 23, 55. So this is my answer for A cube. So now I will start writing in the equation. So A cube minus 6A square plus 7A plus 2I is equal to 0 matrix. So now what is my A cube? Next, my 6 into A square. So already we found what is A square now. 13 plus 7 into A. My A matrix A is, so now I'm continuing in the next line, plus 2I, no. So 2 into the same order only it should have. So 1, 0, 0, 0, 0, 1. Sorry, 0, 1, 0, 0, 0, 1 is equal to 0 matrix also the same order it should have. So 0, 0, 0, 0, 0, 0, 0, 0, 0. So now let us start. So now let me start doing it. So minus, I will be multiplying the 6 with each and every element. Plus 7 also. Plus I will be multiplying for this identity matrix also. So when I look here, this is positive, positive, positive only. This is negative now. So just negative, I'm keeping it aside and adding all the positive matrix alone. So that is this matrix and this matrix. So 21 plus 7 is 28. 28 plus 2 is 30. That is, I'm adding this and this. 3 parts. I'm adding. Next is 0. 34 plus 14 plus 0 is 48. 12 plus 0 plus 0 is 12. 8 plus 14 is 22. 22, 24. 23 plus 7, 30. So 34 plus 14 is 48. 0. 55 plus 21 plus 2 is 78. So now I'm going to change the sign for this. So plus, positive will become negative, negative will become positive. Minus 30, 0, minus 48, minus 12, minus 24, minus 30, minus 48, 0, minus 78 is equal to, so now just check these two. So this is fully positive whereas this fully is negative of the same number. It means it is automatically 0. So 0 matrix is equal to 0 matrix. So now I think you will be clear why I said you to change the sign inside the matrix. So for these types of sums, this will be very, very easy. So instead of having those two methods also, have only one method, which is a clear cut method where it will be very, very easy. So therefore LHS is equal to RHS, hence proved. That's it. Question 17. If matrix A and I are given, then we have to find K so that A square is equal to K into A matrix minus 2I. So now matrix A and I is given, no? So we have to find the constant. The K is some constant. We have to find that constant only. Okay. So now first let us find A square. A square is equal to A into A, isn't it? So I will write A twice. So I will have So I will be doing it in such a way, and next I will be finding A square. So how will I find the product for this? I will be taking, this is anyway going to be a 2 by 2 matrix only. So here I will be taking the rows from the first matrix. Now I will start multiplying with the second matrix. So now I will find with the product. 9 minus 8 is 1. Minus 6 plus 4 is minus 2. 12 minus 8 is 4. Minus 8 plus 4 is minus 4. This is the answer for A square. So now I will apply in the given equation. So A square is equal to KA minus 2I. No. So my A square is 1 minus 2, 4 minus 4, which is equal to K into what is my A? 3 minus 2, 4 minus 2, minus 2 into 1001. This is my I know. So now I will be multiplying these constants inside. Equal to 3k minus 2k, 4k minus 2k minus 2002. So now I will be changing this. So negative to positive. So positive. So this all will become negative. So now I have multiplied this constants now. So I'm going to add this. 1 minus 2, 4 minus 4 is equal to 3k minus 2 minus 2k, 4k minus 2k minus 2. So now these two are equal matrices. So I'm going to equate the corresponding elements. Since every variable is k, I'm taking any one. So first one I'm taking 1 is equal to 3k minus 2. So 3k is equal to 1 plus 2. When this goes to the other side, it will become plus. So k is equal to 3 by 3. So therefore, value of k is 1 over. In 18, if matrix A is given and I is the identity matrix of the order 2, show that I plus A is equal to I minus A into the matrix is given over here. So now, first let us split this into two parts. Three parts itself let us split. So first I will be finding this I plus A. Next I will be finding this second part. Then all together I will do it as third part. These two together as third part. So first let me find what is I plus A. I plus A is equal to 1001 plus 0 minus tan alpha by 2 tan alpha by 2 and 0. So if I add those two matrices, I will have 1 minus tan alpha by 2, tan alpha by 2, 1. So this is my equation 1. Now I will find for I minus a is equal to 1, 0, 0, 1 minus 0 minus tan alpha by 2, tan alpha by 2, 0. So now I will be changing, no? So plus minus is equal to, I will be adding those to 1 tan alpha by 2 minus tan alpha by 2, 1. This is I minus a. Now we have already found what is I minus a. Now so directly we can substitute it. So what is I minus a? I minus a is 1 tan alpha by 2 minus tan alpha by 2 and 1. And my cos alpha minus sin alpha cos alpha. This is what is a given matrix, isn't it? So now we will be multiplying these two. So anyway, this is going to be a 2 by 2 matrix only. So I will take only the rows of the first matrix. 1 plus tan alpha by 2, 1 plus tan alpha by 2. Next here it will be minus tan alpha by 2 plus 1 minus tan alpha by 2 plus 1. So now I will be multiplying cos alpha sin alpha minus sin alpha, and here it will be cos alpha, and here it will be minus sin alpha. So here sin alpha, cos alpha. So now I will be taking my tan alpha by 2 as cos alpha by 2. So cos alpha plus sin alpha by 2 by cos alpha by 2 into sin alpha, and here it will be minus sin alpha plus sin alpha by 2 divided by cos alpha by 2 into cos alpha, and here it will be minus sin alpha by 2 divided by cos alpha by 2 into cos alpha plus sin alpha, and here it will be plus into minus into minus is plus. So sin alpha by 2 divided by cos alpha by 2 into sin alpha plus cos alpha. So now I have found for this, and now here I will be taking the LCM. So when I take LCM for this, I will have cos alpha into cos alpha by 2 plus sin alpha into sin alpha by 2. The whole divided by cos alpha by 2. And here I will have minus sin alpha cos alpha by 2 plus sin alpha by 2 cos alpha. And here I will have divided by cos alpha by 2, and here I will have minus sin alpha by 2 cos alpha plus sin alpha cos alpha by 2. Here sin alpha by divided by cos alpha by 2. Sin alpha plus cos alpha by 2 cos alpha divided by cos alpha by 2. So I have found till here now. So now I will be simplifying these bigger equations to a smaller equation using some formulas. So see here, this is of the form cos x cos y sin x sin y plus no. So what is the formula for this? It will be cos x minus y. This is the formula now. So divided by cos alpha by 2. So we have to get cos alpha by 2 only. So alpha minus alpha by 2 is alpha by 2. So cos alpha by 2 is 1. So we want the same as in equation 1. No, so this will be 1. So here, see, sin minus is here. Okay, fine. So sin x cos y cos x sin y. This is of the form like this, but see, this negative will go to the second position. This will come for the first position. It means that sin x cos y cos x sin y, it is there. So we will be getting sin alpha by 2 minus alpha, which is minus sin alpha. You can do like that also, or else you can take this minus sign out. So if you take the minus sign out, this minus will become plus and plus will become minus. So now it is of the form sin x cos y minus cos x sin y. So only we are changing the sign over here in order to make our equation simple. So therefore here it will be sin alpha minus alpha by 2 divided by cos alpha by 2, and here it will be sin x cos y minus cos x sin y. So here directly I can write sin x by 2 x minus x by alpha by 2 cos alpha by 2. So here it is of the form cos x cos y sin x sin y. So cos alpha minus alpha by 2 divided by cos alpha by 2. So therefore I will have same here alpha by 2 alpha by 2. So this 2 will get cancelled, and here also these 2 will get cancelled, which is 1. So therefore 1, and here it is minus sin alpha by 2 by cos alpha by 2, which is minus tan alpha by 2, and here it is plus tan alpha by 2, and this is 1. So this is equation 2, and my equation 1 is equal to equation 2. LHS is equal to RHS, hence proved. If you have any doubts, mention it in the comment box.
Like, comment, share and subscribe.